All right, well, welcome back. Hopefully you were able to grab something to eat or at least take a little bit of a break. We've had a little bit of a whirlwind tour here so far through web services and Windows Azure. Started out taking a look at WCF, came in and took a look at various ways that we can host WCF up in Azure, and then looked at some of the different storage services and abstractions that are available up in Azure with tables and blobs and queues and the Azure SQL database. And so in this next module, we're going to come back in and look at various ways that we can programmatically, there we go, manipulate data, right? So if I'm writing an application that needs to work with data, what are some of the various ways that we have to go about accessing that data? And so with that in mind, we're going to start out here taking a look at ADO.NET. And I mentioned this earlier in the day, but ADO.NET doesn't go away. It's not like ADO.NET is gone just because we aren't interacting with it directly. The other frameworks that we use, like Entity Framework, et cetera, sit on top of ADO.NET. So this is still very important to understand, and certainly not that we're teaching to the exam, but if you are thinking about taking the exam, you're going to want to make sure that you're comfortable really with all of the techniques that we talked about in this module here. But we'll start out looking at ADO.NET and connections and commands and readers and adapters and tables and data sets and all that good stuff. And then we'll see that that's really a very sort of relationally centric, SQL syntaxy kind of way to work with data. Another great way to work with data is with what's called language integrated query, or just LINQ. And LINQ is an amazingly powerful set of extensions to our languages and compiler and the .NET framework in general that gives us just a fantastic set of tools for processing data. Really, I don't care where it came from, as long as it ends up in some form of a collection or some form of a query expression that I can ship across my application layers. And one of the other ways that we deal with data regularly, other than from relational databases, is through the extensible markup language, or just XML. Of course, XML has been around for a long time, and we've got sort of those DOM-based, walking the nodes and discovering if it's an element or an attribute or a text node or whatever, looking for values, et cetera, and sort of programmatically walking that tree. Or we'll come back in and look and see how we can use LINQ to process that XML data out there. So with that said, let's first dive in here and take a look at ADO.NET. So ADO.NET wasn't really a new version of, it was a complete re-engineering of what was its predecessor, ADO, but some of the same sort of concepts from ADO carried over into ADO.NET. And so one of the things that you deal with ADO.NET is a collection of objects. So imagine that you have a database sitting out there somewhere to which you have connectivity, right? It could be on the same machine, it could be on the network, this could be an Azure SQL database, I don't really care. But somewhere you've got a database that you'd like to interact with. And then you've got a set of tables or things like that, and it could be views or procedures or functions or whatever. They might have relationships that you're doing joins against or whatever. But good old relational database. And then I've got a client application running somewhere that wants to be able to consume or manipulate that data in some way. And so one of the first things that I have to be able to do is to be able to establish a connection between my client application and that database on the back end. Right? And so in ADO.NET, we have a collection of DB connection, or just in more generally connection objects. And these are provider specific. Notice that I have an asterisk up there on the word connection. And down at the bottom of the screen, I say that the things that are marked with asterisks are ADO.NET provider specific. And that means that, for example, if your backend database is Microsoft SQL Server instance, and you've chosen to use the .NET provider for SQL Server from Microsoft, then I have a SQL connection object that I would instantiate to create one of those guys. If, on the other hand, I was using OLADB, I might have an OLADB connection or an ODBC connection, or et cetera. It depends on the provider that you choose as to the actual name of the class that you'll go to instantiate there. And then on the screen there, I just added in some sample source code, right? So connections require a connection string. And the actual attributes that you'll place into a connection string are going to be provider specific. So you'll have to read up the documentation on the provider that you're working with. And actually, I didn't put it on a slide here, but one of the sites I love to use to get connection strings is just connectionstrings.com. Tons of great connection strings for different types of clients against different types of servers.
And SQL Server, by the way, a SQL database gives you the connection string right from the portal.
Yeah, and we'll see that. So if you have an Azure SQL database and you want to connect to it from a variety of different clients, the portal for the database itself will show you some of those. So great point there. But so if you think about it, though, if I'm going to connect to a database, I need to know where that server is. And so that could be a computer name, it could be an IP address, it could be something like that. If it's something like SQL Server, one instance of SQL Server can actually host multiple databases. So then I need to know which database do I want to access on that server. Then what about credentials? You know, do I use clear text, username and password? Do I use Windows authentication? Is the connection encrypted? A whole bunch of other things. And so it's those sorts of attributes that we're specifying in our connection string. And then we'll open a connection that uses those attributes to actually make the connection to the database engine on the back end there. So in there, I've got this SQL connection object called connection. I'm newing it up and shipping in this connection string. And you'll notice that in the sample code there, I'm wrapping it up in a using clause. And the reason for that is that these SQL connections not only consume resources here on the client side, but they're also consuming resources up on the database engine side. When you have a connection with a server, you're consuming certain server resources for it to track your state. You might have locks against certain objects or things like that that are being held. And so we want to make sure that when we're done working with that SQL connection, either because we successfully executed all the code, or what if there was an exception and the exception caused us to branch out of the execution, I want to make sure that we close up that SQL connection. And so SQL connection and really most of the objects that you work with in ADO.NET are disposable. They implement the iDisposable interface, and the using pattern is a recommended practice when you're working with disposable objects. So I'm basically saying, hey, go use this connection object for the scope of statements that are within the curly braces, but if for any reason we exit the using block, we naturally branch out of it, or we throw an exception or something like that, then it will make sure there's effectively a little hidden try-catch finally block in there, and then inside the finally it'll make sure to call the dispose for me, so I don't have to make sure to remember to do that myself. All right, so at this point, I've got a connection object defined, but that doesn't mean that I actually have the connection open yet. Right, we'll get to that. So the next thing that I'm going to want to do through that connection is submit some statement. Right, this could be a select statement. They could be inserts, updates, deletes.
Stored procedure name.
Stored procedure executions. Whatever. If it's a stored proc, there might be parameters, etc. In fact, really in general, even if it's not a stored proc, you can have parameterized SQL statements with placeholders for the values that you stick in to help overcome SQL injection attacks. And you know, the old way of doing the concatenated string or whatever is severely frowned upon. So SQL commands support parameters and parameterization of statements and all that good stuff. But let's say it's a simple select statement, right? Select star from some table up there. I'm going to ship that up to the server. In order for me to actually do that, though, I have to first open the connection. So I have to tell it down to actually go effectively connect. And this is something else that you'll deal with ADO.NET is this idea of sort of temporary connection. You don't want to open the connection until you absolutely need it. And then as soon as you're done, you want to make sure that you close it and get out of town. And then you say, well, I might be turning right around again and opening it right back up. Well, ADO.NET has this feature called connection pooling. So it'll go ahead and sort of keep your connection around in a warm state. So if you return and try to use it soon, it'll just spin it right back up again, and you can continue working with it. So best practice, imagine turning your car off and turning it back on at every red light. You wouldn't do that with a car, but with a connection, unless you have a reason to keep it persistent and open, that's what we recommend you do. So I've got this connection.open, and then I've got to decide, how is it that I want to deal with the data that comes back to me on the client side? And sort of the easiest way is, or the most primitive ways, maybe that's a better way to say it, is sort of this fast forward only cursor, right? Where I just get a set of rows and I just want to loop through the rows until I get to the end, and then I'm not going to look at those rows again.
No locking.
Right? Yeah, no locking. And I also don't have all these heavy cursors that manage navigation and optimistic concurrencies or pessimistic concurrencies. What happens if I've looked at a record and then I come back and I see it again? You know, all those issues. Fast forward only cursors are pretty lightweight. And so the type of object that we use for that in ADO.NET is this data reader. Now that's also, I should mention the command is provider specific, so I'd have a SQL command if I'm hitting a SQL database engine on the back end. The data reader object is also provider specific, so I'll have a SQL data reader that knows how to manipulate that data. And so here I'm using this SQL data reader, but the way I'm actually creating is I'm telling the command to execute its statement and return a reader back to me. So I get that reader back, right? And so now I've got this reader, and that little yellow triangle on the screen sort of represents this cursor that's sitting at the top of the record set. It's actually not pointing at a record right now. It's at the beginning of the file, if you will, of this result set that has come back. And so what I can do now is loop through those rows by calling the reader's read method. And what the read is going to do is advance that cursor, and if it successfully landed on a record, it'll return true. And so then I know that the reader is pointing at the current record, and I can then go into the individual columns in that and retrieve those. I need to know what those columns are. I imagine that because of my select statement, I said, select the position ID and then the latitude and then the longitude. I know the ordering or the ordinals of those columns, and so I'm going to make sure to be able to retrieve them the right way.
Now you can do that numerically or with the actual column name.
Yeah, and numerically is going to be better, and you also can do it strongly typed. You can say, hey, go to column 2 and return it to me as a double, so that you get it back in a strong type there. So yeah, definitely. But anyhow, so I can just basically run through that while loop until read eventually returns false, right? And so it's going to get down to that last record, and then one more read will return false. I don't embark the loop, and then I can move on past it at that point. So I might be doing console write lines. I might be doing, sort of who knows what inside there. If I need to see the data again, I've got to requery it, or somehow have cached it locally some other way, or stuck it into a collection or something like that to have taken a look at it there. But for me, I think that's really sort of the core. If you get that, you get most of ADO.NET, right? Now, there are some other abstractions of dealing with data on the client side. We do have a blank slide there. Sorry about that. We do have data tables. So here I've got the same client, and I could create in memory a data table object. And a data table object could just be a way to store data in memory. It might not have anything to do with relational data. You can define the columns, you can add rows, you even get a simple sort of select model on top of this that you can use to query those. But quite often we do have a relational database engine on the back end. I can create a connection object, and then what I can do is I can define this thing called a data adapter. And the data adapter is going to give me a way to manage the data in the data table, which is a client-side representation, as comparison to the data that's up on the server there. And so there's two sets of commands here. I'm going to need one command that I can use to query data, and then I'm going to need another set of commands that I can use for inserts, updates, and deletes, right? So a data adapter actually has 4 commands. These are all provider specific, so I'll have a SQL data adapter, and it'll have a collection of SQL data commands, or SQL commands on it. But then there's a method on the adapter called fill, and I can call the fill method on the adapter and say, hey, adapter, go run that select statement, get the data that came back to it, or with it, and fill this data table up with that schema and with those rows. And then I can actually manipulate those rows in the client side. This is not a fast forward only cursor. This is random access. You can go grab any row you want, you can manipulate columns, you can delete, you can insert, you can update, you can do whatever. And the data table is sort of tracking all of that state for you behind the scenes.
The nice thing too, you typically can assign it to client side grids and stuff like that.
Yeah, so we could be doing data binding and things like that. Now the data reader you can actually bind as well, but then if I do make changes on the client side and I want to ship them back up to the server, then I can call the update method on the adapter. And it's going to take all the energy it's going to do all the work, let me say, to actually go look at the state of your data table, figure out which rows need to be inserted, which ones need to be updated, and which ones need to be deleted up on the server side. Of course, now I have this whole concurrency issues, right? What if a change happened to the same records up on the server side? And how do we deal with those collisions?
Conflict resolution.
Yeah, conflict resolution, right? And I'm not very good at conflict resolution, so I always get in trouble and I can't get out of it. But anyhow, so that's the data table and the data adapter. Now that's just one data table. A lot of the times, if you have one, you need others, right? And so that's really where this idea of the data set comes in. And the data set gives me a way to build a structure in memory that can host any number of tables, and they can have relations between them. I should mention that the data table and the data set are not provider specific. And the reason that's important is that you could have a data set that had one table that came from SQL Server running in an Azure SQL database, and another one that came from Oracle running in a Linux VM running up in Azure. Right? And you could actually pull both of those together and even apply a relationship between them that you could enforce inside your forms and validation and all that other kind of stuff. So it's almost like it's its own little in-memory database, which is really cool.
Minimizes all that network traffic too, chatty traffic going back and forth.
Yeah, it minimizes the traffic going back and forth, but it also pulls those watermelons down the garden hose as you populate those tables with rows that you end up never using, right? And so that's the downside of the data set is, yeah, it's cool. It's also really expensive, right? It's just, it consumes a lot of resources. We tend to ship a lot of bits back and forth across the wire. And because of that, I'd say they've kind of fallen out of fashion. Right? I can't think of the last time I wrote something that either provided or consumed, data sets out of there. They're still there. They're still very cool, very powerful. I just think they've kind of fallen out of fashion. We've sort of moved on to other patterns for working with data. Another way of thinking that, especially as we start, thinking about building mobile applications, I don't want to ship a whole data set down to a device and make them handle that if they're not going to end up, using all those rows.
So this was good in a corporate setting where network bandwidth was not really an issue.
Yeah, definitely. Yeah, especially in web services, Soulful Web Server. In fact, I would say that was probably the most popular demo for an ASP.NET web service for the first couple of years, was building a service that shipped data sets back and forth, right? And you're like, wow, this is so cool. And then your IT manager goes, you're killing my network, stop. Right, so anyhow. So with that data set, though, remember there are data tables in there, and so I can still have different data adapters with their own select, insert, update, deletes, and all that good stuff, and I'll have a data adapter for every data table. And again, I could have one data adapter that's pointing at a SQL database, another data adapter that's pointing at some other database. Although, why you would want to go to anything other than SQL, I have no idea.
Definitely.
But anyhow, all right. So let me jump over and take a look at querying some data. Again, I've got my development VM here. And just to keep everything sane, I'm going to pull up my snippets here. And again, if you go to my blog, you have access to all of these guys. Oh, I don't need the actual markup. There we go. That's better. And so one of the first things I want to do is actually have a set of SQL data that I can use, that I can manipulate. And so in the last module there, Bruno was talking about Azure SQL. There we go. Databases. So I'm going to jump up here to the management portal. And give it a second to populate the menu over here. All right, so here's SQL databases. And you'll notice, in fact, that I actually already have a database called positions. I'm going to use that one, but I'll go ahead and demo everything I'd need to create it, right? And so basically, I can come in here and click New. I'm going to create a new SQL database. You've got a couple of choices here. You can also import them from backpacks or data tier applications and pull them up that way. But I'm going to come in here and just do a quick create. I can call it positions demo. Sounds good enough. Now, you'll notice that I'm creating a database, and the server is sort of the second thought. Like, oh, sure, you want a database. Oh, well, where do you want to put it, right? If you were on-prem with SQL Server, you'd go to the server and then say create a database, right? You don't have this sort of abstraction of the database as being opposed to this on a specific server. So down here it's saying, well, where do you want to go create it? And you'll notice that I've got a number of Azure SQL instances already in place, or I can come in here and create a new one. And I'll go ahead and create a new one just so we can see that process. So this is actually a virtual SQL instance. It's not a real physical instance, and that means that there's going to be some constraints on what I can do in conjunction with the databases that are in this same instance. For example, I can't do a use statement and switch from one database to another because it's a virtual instance. They could actually be physically running on totally different servers somewhere else, and I can't just change my connection context, from one to the other.
Can't do distributed transactions across multiple databases?
Yeah, we don't get distributed transactions. We don't get link servers. I can't do three-part names. Your schema.object, not database.schema.object, right? Or instance.schema.database.object. So
if you needed that in the cloud, you'd do what? Like a SQL Server VM?
Yeah, if you need that, then you go to a VM, you install SQL Server in it, and now it's SQL Server, just like you have on-prem. Right? You also have no idea of physical structures, right? So notice it's not asking me where are your MDFs and NDFs and LDFs and what are your partitioning schemes and all that kind of stuff, right? So all the physical aspects are gone. You don't get to mess with that. And so for the DBAs that are going, man, thank goodness I don't have to mess with that. This is great. For the DBAs that are going, what do you mean I can't do partitioned indexes? That's when you go to SQL inside a VM, right? That you've got that choice, depending on sort of what it is that you need.
The other thing I get, by the way, when we do that, they say, hey, but I've got on-premise resources I need to be able to interact with. The answer there, of course, is virtual private networks.
Yeah, which are going to tie into SQL VMs or a SQL server running in a VM. But we do also have data sync. You can hit SSIS up against these guys. They're regular TDS endpoints. You can hit them and query against them as you would any other SQL Server instance. The downside is they're over there, right? So if you're going from on-prem up to Azure, that latency obviously is going to be higher. So it's just not going to perform as quickly across the wire as you go there. So, all right, so I'm creating a new instance, though. I get to come up with effectively my SA login. So I'm just going to call this SQL admin and give it a password. Man, I'm loud. All right, and then create a database. And you'll notice that down here it's provisioning this positions demo. And it tells me that this is going onto a new server, but it doesn't know the new server name. And I didn't give it a name, right? So databases you can name. Servers get random sequence of characters, right? If you don't like it, cuff. Right? That's just the name of the server.
But at least you didn't have to go to any one machine. You weren't constrained. I mean, you have this freedom, too, at the same time.
Yep. And, the data region, yeah, this guy could have been in East US, West US, again, these data centers. And same constructs, just like Bruno was talking about with storage, you want these databases close to the applications that are going to use them to minimize latency and egress data.
So there is no create database command, per se. You're just at the port.
Actually, there is.
You can do that.
You can actually connect directly to the server. There is a master database, and you can issue create database statements. And this is where I want to make sure I'm being honest. Databases are billable resources, right? So as you go in, well, databases, it's the data that you put in them. But effectively, other than the single 20 megabyte free SQL database that you get, the minimum is a 100 megabyte database is billing level. And so if you go in and create a database, it's going to be a billable unit, for a certain amount of time. So issuing a create database statement is extremely simple to do. Be careful. Right? So just being realistic there. So anyhow, this server name was ode 9B5U5EM. There it is. Okay. And I wasn't careful about where I created it. That ended up in Southeast Asia. So now you got something in Singapore, right?
Finally.
All right. Woohoo. So anyhow, so I've got this database here, and I can navigate into it. Bruno was talking about being able to get connection strings, so I can see, view connection strings for ADO.NET, ODBC, PHP, JDBC, and I can click on that and get awesome connection strings back here that I can use. All right, so I did mention that I've already got one. Oh, the one other thing I want to mention is that this is now an Azure SQL database that's exposed on the internet. Are people going to be coming in and pounding this server? Well, the server that it's running on, and I can get to that server if I come over here to the dashboard portal. There's a server link that'll bring me to the server. And so now I'm looking at the server. I can see that I've only got a single database on that server, but I could add other databases, import, export, things like that. But if I go to the Configure tab, you'll notice that there's this set of allowed IP addresses of which there's no current rules. This box up here is just letting me know, hey, FYI, this is who you're coming into us as, but that's not a firewall rule. Down here I can add new rules, although I have none. The only rule I really have is this one, and that's saying allow anything else that's running in Azure to connect to this Azure SQL instance back here, right? And so really, in fact, I'm going to go turn that off. Because if I do that, you guys could all go spin up VMs and start to attack my SQL box, right? Well, I didn't tell you the password, but you're going to see it in clear text, right? Here in a little bit. So the other thing that I can do then is come in and say, no, just give my IP address access to that. And they give you a handy little button here to add that. Now, if this were back at work, you might want to do something and then edit it to be like, your whole class C subrange, or, talk to your IT admins and they'll tell you, for your proxies going out or for your VPNs going out or firewalls going out, whatever they are, there will probably be some valid IP range that represents your machines at work. And you say, oh, let machines within that range get out, but nobody else, or something like that, right?
What about like mobile workforces? There's some challenge there, like if you're getting your IP address from Starbucks.
Yeah. If you definitely have IP addresses that vary, that's when you start going to service-based access to this database on the back end. Nobody connects directly to the database. They connect to a service, and the service proxies that access out. Now, the other one that you could do, and I call this the fire me please rule. is you just put in, you know, anything from 0.0.0 all the way up to 255, 255, 255, 255, and I've now opened this up to the world, right? My password is password. Everybody jump in, have fun, right? So don't do that. I do it a lot for demos. Don't do that on your production servers, please. All right. So I'm going to leave the one in there that I had, and then the other thing I always forget to do down here is hit save.
Question for you, Brett. Could I actually connect up to this from my on-premises SQL Server Management Studio?
Yep, and that's what I'm going to do right now. So I can now then go back to my database. Well, even just back over here to the portal for this guy. And this right here is the fully qualified host name for this SQL Server instance. Now, there's actually a Silverlight-based management tool that you can use. I'd much prefer SQL Server Management Studio myself. So I've got SSMS installed down here. I can come down here and open up my favorite SQL Server Management Studio. And here you'll notice that this is the same tool that I could use for connecting to local databases, but I can just paste in that fully qualified host name. If you do, well, the port should be 1433 for an Azure SQL database. That's the well-known port for SQL Server. SQL Azure right now only supports SQL authentication. And remember when I created it, I created a login account called SQL Admin with a password. And I can hit connect. And like a bolt of lightning, it rockets to the screen, amazing you with its speed and agility. There it is. And as I open up databases, there's that positions demo database. Notice here it looks kind of like a SQL instance, much more pared down Object Explorer, but it's there, right? And so anyhow, I can come in here, issue new query, and I could get in and start working with this. Now notice that the query that came up, when it comes up, has me in the positions demo database. You could actually connect to master. So I could come up here and change this context, maybe. Let me disconnect. Sorry, just reconnect here. That should drop me back into master. I mentioned you can't do use statements. So if you get into a database, you have to disconnect and reconnect to change context. But Bruno was asking, can I do a create database? Please add this. And I can just run it. And no problem. I just created another database, right? And that's basically the same process as if I would have gone back here to the management portal and added a new database, you know, using the way you saw me do it before. It's just now it already knows what server it's on and all that good stuff.
Hey, Brett, I'm concerned about the data crashing. Is there protection against that?
Yeah, so these guys are all running, you know, they have their own replication or their own redundancy going on inside of those Azure data centers up there. So that's, again, things that you would have a hard time doing in-house. The way that data is being replicated behind the scenes, there's really not convenient shipping technologies to do on-prem what they're able to do.
Triple replications.
Triple replication, right? So that's pretty cool. All right, so anyhow, so that's the idea there, and I can now get in and just start issuing SQL statements against this guy, right? So I mentioned that I already had one done and in the oven here, so I want to go connect back up to that guy, and it's this server down here. And really, there's nothing different about this one than the other one, other than I know I've been working with it. So if there's any code I have that's specific to it, I know that'll be correct, right? And you'll notice that I've got this positions database on there. And I could actually come in here and go open up SQL scripts against this. Let me go open up out of my assets. I've got a script out here that creates a bunch of tables and data, but not the database itself, because I've already made the database, right? If you wanted to run it locally, I've got another script that creates the database and then all the objects within it. But I'm going to open this guy up. And this goes in and creates, again, remember going back, we were talking about my parents cruising, and I had this position data that I've been playing with. So I have a table that represents the different cruises that they've taken. Within there, I have the different places that they've been, the time zones that their positions were in, etc. And so I've got the code in here to create those structures as well as to populate them. So I can just come in here and make sure I'm in the right database and just execute this. And I'm actually running this from my dev workstation, which coincidentally happens to be a VM in Azure, but forget that, right? That has nothing to do with it. And it's running against an Azure SQL database that's up there in the cloud, right? And so here it is. It's, you know, going through, running them, inserting the records and all this. And this is just a regular good old SQL script, just like you were used to on-prem. And then it queries it and returns some data back so I know it works. And then I can look in here and I can see that I got all my tables and all that good stuff. Cool? All right, so I've got my database, and now let me close this up. Don't need to save my scripts. And let's get back to looking at working with the data then. So I'm going to go spin up Studio. And yeah, I'll keep it open bigger. Sorry. I want to, first of all, we already went through and created the positions database. We talked all about that. But I want to come in here now. I'm going to create a new console app. It's going to be a Windows console application. We'll stick it out in my MVA. This is data access, demos begin. And we're going to call this data access demos dot. Yeah, that's good enough. All right. And so I've got this program.cs out here, and I'm going to add in a little method call here that's going to go work with a SQL data reader. And I'll just stub that out for now. So actually, I should show you what I was doing there if you haven't seen that yet. So the Visual Studio refactoring stuff is not new by any means. But I typed this method name, and it's a method that doesn't exist. And so, in fact, I can see this little blue box over here. And if I hover over it, it'll give me an option to generate a method that has that name and 0 arguments in there. And I can get there really quickly. Whenever you see those blue dots, you can just hit Control period to drop them down. And usually the top item in the list, if there's more than one, is the one that you want. So my fingers just know how to do Control.Enter, and they do it before my brain thinks. And now it's stubbed out this method and left a little exception behind to remind me that I need to go implement the body of that. So I've got this SQL data reader, and we were talking about over here connections and connection strings and all that kind of stuff. So I'm going to come in here and create a connection string, and I need a connection string off to my database, right? Well, remember Bruno was talking about how in the portal, if you have an Azure SQL database, let me get back to my databases. Here's positions. On the quick launch page, I can come down here and view the connection strings. And so I can actually just copy this here and paste that in, right? Now, it didn't know my password. It knew the SQL admin login. And you'll notice that when you're hitting these, it's nice if you qualify your login name with the server name. It's kind of an odd convention if you're used to on-prem, but that's all that is log me in with this name from that server, right? And then I need to stick in my password. And so this is my high-tech password. Please copy it. No, don't. But I put that firewall rule on there, right? So I know that hopefully nobody else is going to get in and mess with my demo. Please don't try. So anyhow, so there's my connection string, and I've got that semicoloned up. So now I can come in here and create a connection. And I don't have the namespace imported. I'll control dot and then pull in the system.data.SQL client namespace. That's where the SQL ADO.NET provider lives. So I'll pull that in. I'm going to create a connection called connection, and this is going to be a new connection, and I'm going to pass in that connection string that we created up above. Right? So there's cool. So there's that code then, right? And now within there, I want to come in and create a command. And I'm just going to call this guy command, and we'll do something amazing. This is going to be a new SQL command. Actually, I think I want reported at, latitude, and longitude. Now notice what I'm typing in here is actually a SQL statement. I think I only want to grab a few of those. Let's grab like the top 10. So notice this is SQL, and this is going to come from my dbo.positions table that's off in that database, and that's going to go through the connection that we described up above. All right, and so I'm going to go flip and look at my code there, make sure I didn't do anything really stupid there. Oh, I do want to add a little bit of code at the end of the main body. After we call this, we'll put a little pause in there to give you a chance to take a look at the results that come back. So we'll go run the SQL data reader, and then we'll pause for you to press enter when you're done there. So I've got all that, and then my query was select top 10 position, reported at latitude, longitude, that all looks good. And then what I want to do in there, I'm going to steal this statement here. I now want to take that connection and open it, because I'm now actually going to go try and call it. And in there, then I'm going to use another object, which is going to be my SQL data reader. And the way that I'm going to get a reader is by telling my command to execute and return a reader, sorry, there we go, back to the caller. So execute the command and return the results as a data reader and populate that into my data reader object for me. And now I can go in, and while the reader can read, remember I talked about moving that cursor forward, then I want to go in and do something, and that's going to be where I just basically report out, what was the position, what was the reported at the latitude. Notice I'm accessing these columns here ordinally and pulling them back that way. All right. So with that said, I ought to be able to go run this guy, and there it is. Right, so this is my console application running, quote unquote, on my development machine, going up through to Azure SQL, retrieving those data, coming back and looping through them. If you look at that code, though, that's a lot of code just to pull back, right, some simple position reports. I had the connection string, the connection, the command, the reader, the loop, the iterator, and all that kind of stuff, the console write lines. And that was just for one table. What about for all the other tables I want to see, right? So that's why I was saying earlier, man, I've written that sort of basic structure of code so many times through my career. I mean, I can't even count it, right? And so that's really where you start looking at some of the other data frameworks, like Entity Framework and that kind of stuff, is they're really trying to minimize that kind of code to get us out of, marshaling between C# and T-SQL, right? I've got one statement there that's got both languages in it. And as the developer, I've now got a responsibility for sort of mastering both of them.
It's kind of brittle, too. I mean, you've locked yourself into those column names, and
yeah.
you'll have to modify code if you modify your structures.
Yeah, there's no mapping between this query and the database. If the DBA or DBA changes a column name or something, my scripts are broken, right? So anyhow, so this works. It's fantastic, it's cool, and it's the core foundation that the other things sit on top of. But for the most part these days, we've tended to move away from it. That doesn't mean you can't use it. That doesn't mean you don't use it. I'm sure many of you still use ADO.NET on a regular basis. Anyhow, just trying to set us up for what's coming next, right? So that's SQL Data Reader. The other sort of, or at least next data access technology that we'll talk about is LINQ, or Language Integrated Query. And this is cool. I love LINQ, right? LINQ is basically a very, very powerful set of language extensions, compiler capabilities, .NET Framework function or elements to allow you to manipulate data in memory. And so if you think about up at the top, sort of the places that we get data from. We get it from relational databases, if we're pulling SOAP or just plain old XML out of web services or getting them out of databases. A lot of the times we have XML coming into the organization through various transfer mechanisms. Or it could be that we just have collections of data various ways. Imagine I go through the Azure Management APIs and I query all the SQL databases. I'm going to get back this collection, right, that I'd like to be able to process or manipulate or filter or do something with, right? And so the problem that we have is that we've got different programmatic APIs for working with all of these. With ADO.NET, we have data readers and adapters and connections and commands. With XML, we had the DOM or XPath or something like that. With collections, we had enumerators that we grabbed to get over those. And so it's not that we couldn't write the code to do that. It's just everything was different.
Could you do a join using this? Let's say from XML to SQL Server. Does that?
Well, in code, you'd have to make that join mechanism yourself. Right? I have to get the two collections, somehow decide how I was going to match them up, somehow have a third thing that I dumped them into, but no, you couldn't. So, all right. So the idea is that LINQ is there to come to the rescue, right? It's going to give us this common programming technique that we can use to access data regardless of where it comes from. Now, that doesn't mean that databases are magically object-oriented all of a sudden, or that XML is. What we have in the middle there is a number of link to star frameworks or providers or whatever you want to call them, right? So we have Entity Framework, and we have link to entities that we can use to hit relational data structures. We have link to XML to process XML data, just link to objects. And underneath there, link to objects is really working on IEnumerables. So pretty much anything that's enumerable, we can do link queries on top of. And with frameworks like Entity Framework, we have queries where we take the intention of the query and we can ship that across application layers. So a server could actually say, hey, Brett, here's how you query positions. And give it to me. And that's effectively the select star from. But I could say, well, I don't want all of them. I want you to filter them, or I want you to order them, or whatever. And I can manipulate the intention of that query. And that's what an iQueryable is. And then I can ship that intention back up to the server, and then let the server materialize that data, ship it back to me as an IEnumerable that I can now go walk. Right?
Rather than them sending all the data across the wire and filtering it on the client.
Right. So those iQueryables are fantastic. I get to treat it like it's a local query, but when I execute it, it's actually being passed back up to the server and being executed.
So the network won't get killed. You get only what you ask for.
Yep. Unless you ask for everything.
Yeah. Bad programming.
All right. So link is, again, basically a way to query data in memory. It's effectively really a bunch of extension methods to IEnumerable, as well as some other fantastic types and things like that, as well as language and syntax things. I say they're composable, and that's because we have these expression trees. We understand the intention of a query. So I can start with a query, and then I can come in and add additional intention to that query. And it's not until I actually try to materialize the data that then it goes and executes there. And similar, as I was mentioning, with iQueryable, we can ship these across application layers. We say that the queries are composable. You can build them over multiple statements. You can compose them over time. And they have deferred execution, because they don't execute until you go to retrieve the data. Now, there are what we call greedy operators, things that you do that cause it, like an aggregation, has to go get all the members in order to do the aggregation to give you the result, right? But as a general definition, we can say they're composable and have deferred execution. So let me jump back over here. I'm going to go create another method here. I'm going to comment this guy out, and we'll make another method, link to objects, demo, stub that out, cool. And basically here, I want to go create, let's go build like a string array of names. And I want names of other evangelists on our team that have done MVA courses. So we had Adam, and I'm going to try and put these in no particular order. We had Michael. We had Jeremy, we've had Bruno, of course, good old Jerry. What's he just said he was up to number 7 or something like that. That's pretty amazing. And I'll just stick myself at the end. And if there's any other teammates that have done it, I apologize. I'm not trying to leave you out, just trying to come up with an array. Right, so now I've got this array of names up here. And if you think about how you would process that array, what if I wanted to sort the members in the array, right? I could come in and use like the array class. You know, it had a sort method that you could pass another one into, but that return, you know, it just wasn't obvious how I would go about doing it.
It wasn't as natural like a query.
Right. It would be kind of cool if I could just walk up and say, hey, names, you know, go sort yourself or something like that, or order by or whatever. Now, in fact, if I look at names right now, you'll notice that there's actually a ton of methods off of that. Let me do something, though. I'm going to jump back up to my using statements, and you'll notice there's this using system.link. I'm going to comment that out. All I've done is comment out that single using statement. I'm going to come right back down and again investigate the methods on names. And notice that list is significantly shorter, right? And so it's the system.link namespace that's pulling in all of the extension methods that support link on top of these IEnumerable collections back there, right? And so I can then go in and do some pretty cool things here. So let's go get sorted names. And actually, I just call it results. And I'm going to use the var keyword here because sometimes with link queries, you're not necessarily sure what you're going to get back until you've written the query. So var is great because it's still going to be strongly typed, but I'm going to let the compiler look at the right-hand side of the equal sign on my initializer to figure out what the actual type is. And we've got these cool sort of from, let, where, order by, select type queries that we can run, where the from comes first and the select comes last, right? We call them comprehension syntax queries, and they may seem a little bit backwards to you if you're coming from a relational database engine, but they actually make more sense because it's hard for me to tell it what to pick if it doesn't know where it's coming from first.
Pick the source first.
Yeah, so, and in fact, you'll find that most of your SQL optimizers do that anyhow. They look at the from clause first, and then they figure out if the rest of the statement's valid off of that, right? So really, this is more logical. And so we've got these names over here. So what I want to do is go get each name in names. But what I'd like to do is take the names and order by the name themselves, right? So sort by the names, and then return the names back to me. Cool? So this is actually going to be a bunch of names. And so if I hover over var, it tells me that what I'm going to get back is an I ordered enumerable, so it knows it's sorted data, of T element. And down below it says where T element is of type string. Right? So I'm basically going to get back a sorted collection of strings from this. Right? And so then I can turn around and we'll do like a for each name in results, and we'll just CW out the name.
That could just as easily be an array of objects, too.
Yeah. Oh, yeah, yeah. Well, a string is an object.
True.
Yeah. Yep, yep. So anyhow, let me go in and run this then. And you'll notice Adam, Brett, Bruno, Jerry, Michael came back. So it took that data and sorted it for me. Pretty cool, right? So that's sort of LINQ at its heart, right? And in my case, I'm sure most of you probably aren't going to go hard code your data as string arrays, right? But imagine that's coming as a collection coming back from a database. There's LINQ to data sets. So ADO.NET, you could go populate a data set and then do LINQ queries on top of that. It could be coming back from an entity framework model. It could be coming back from a good old LINQ to SQL if you're still using that, whatever. Various ways that we could be getting these collections back to filter. So I don't want to run too late on time here. I do want to show you one or two other ones. We saw sorting them. We could filter them. Right? So let's go back here. Bruno and I are here. So let's filter them out and say, well, where the name. Now, name is a string type. Right? So when I hit dot on name, the compiler's smart enough to look at all the stuff in here and figure out that name is a string. And I can go in and do the contains operator on that and pass in a capital B. Right? And now when I go run this, I only get Brett and Bruno coming back from that result set. Right? So we sorted it out, only the names that have the letter B in them. And I could be even more specific. I could say starts with B or something like that. What would be kind of interesting, though, is what if I wanted to get only ones that had an even length? Right? So I could come in and say, okay, well, take the name and then check its length, modulus that with a 2, and see if that's equal to 0. Right? And I could run it, and I get Adam, Brett, and Jeremy. So Adam has 4 letters, Brett has 4 letters, and Jeremy has 6. So those are all even numbered characters in the names, right? But if I go back and look at the query, it's not very obvious what the heck I mean. I've got to go read that expression as a human and go, what the heck is he asking for? Oh, he's asking for names whose lengths are evenly divisible by 2, so they're even. Okay.
Are you saying I'm odd?
Yes, you are. All right, so it'd be kind of cool if I could walk up and and say, hey, only return names where they have an even length or something like that. That'd be kind of cool if I could do that. It's not on there, and I don't own the string type. I can't walk up to Microsoft's sealed string class and add a method to it, or can I? Right. So those are extension methods. Extension methods are really, I call them a compiler trick. I'm going to come in here and add a class to this. I'm going to call it string extensions. And I'm going to make this guy a public static class. And by marking it static, I'm going to make sure that I only have static members. So I'm going to make another public static member that returns a bool. And I'm going to say, what did I want to call it?
Have even.
Have even. Or how about we'll say has even length. And I'm basically going to take in a string. I'll call it the source, right? And then I'm going to run that exact same expression, and I'll just return if the source.length mod 2 is equal to 0.
Typo, event length.
Oh, thank you, right? The thing is that I'd have to now go call this method somehow, and that's not what I want, right? I'd have to come back and say, okay, well now go to string extensions dot has even length, and then pass in my name. And that's okay, but that's not what I wanted. I want name dot has even length, right? And so all I have to do to turn this guy into quote unquote an extension method is to tell it what type it extends. And the type it extends is this type right here, string. It extends string. So I just put that little word. It says it's this type string that you extend. And now when I go back over here, I can say, hey, name.hasEvenLength. Cool. And now I've got a much more readable query. Somebody can come in and look at that and go, oh, yeah, you're looking for names that have an even length. Okay, cool, I get that. And I can run it, and it works. Pretty cool stuff. So those are extension methods. And in fact, it's those extension methods that make link possible, right? So we have a whole bunch of other ones here. In fact, I could take this. Let's get rid of this. Take the results and reset it equal to the results dot where. And then I can filter this in. Where the name, where the name goes to, and this is a lambda expression, name dot has even length or something like that, right? So here's an idea of these composable queries, right? I can sort of build them over time. Why don't you like me? Where and goes to, oh, because one's ordered and the other one's not, right? So I got to do an order by dot order by. And goes to just sort by n, sort by the name. That should get rid of that. Right, cool, all right. And let me do one more thing here. I'm gonna set a breakpoint on this for each. And you'll notice then I'm about to iterate through these. So I go say, hey, for each name in results, and when I step over the n, notice that I jump back up into the link query.
Lazy,
right? Yeah, this is that deferred execution, right? This lazy execution. So it didn't actually go and try and execute the query until I tried to material the results. Say, give me the data in. And it goes, oh, well, then I better go figure out what's in, right? And so then it steps through that and returns my guys back to me. So there's that deferred execution and composable. All right, so that's pretty cool. Let me jump over and we'll hit link or XML here. So if you can't tell, I love link. It's pretty cool. I wish we could talk about it longer here. But XML, extensible markup language, actually used to be one of my favorites until link came along. But anyhow, so XML is just good old XML. In fact, people call it plain old XML, POX, right? Which doesn't sound so nice. But anyhow, here's an example over here. I've got some sample position data broken out into XML. Notice I've got, parent and child elements. I have attributes and all that kind of stuff. And so we can process this data because it's XML and because XML has a fantastic rigid specification. You can read all about it. I put a link there on the screen. And I really mean that. If you work with XML even a little bit, or just even work with data systems, I think it's worth your time to go read the XML spec because it just makes you start to think about the structure and how they did things and why it works and all that good stuff. That doesn't mean you have to love it, but at least you'll understand it better, right? But along with XML, there's also a whole family of related standards that actually probably help to add to the confusion around XML. But we've got schemas and XPath and XQuery and XSLT and XSLFO and so anyhow, lots of different specifications around that. And so typically the way, at least in the past, that we would work with XML in code is through the objects that are in the system.xml namespace. And we have the XML document, and that gives me this document object sort of info set hierarchy of nodes. And I can get the root node, then I can ask it for its children nodes, then I can ask them for their children nodes, and you can sort of recursively walk this tree here. And that's fine for smaller documents, but if it's really big, having to take this whole document and turn it into an in-memory collection of nodes can get pretty expensive. So there was this other sort of streaming type SAX readers that would read the document in as a stream, and then you'd fire events. Tell me when an element of this type comes along or something like that. So we've got both of those. We can also programmatically create them. I'm not going to demo that here. There's lots of demos going out there. And sort of if you think about XML, if it's just text, you could write them as strings, or you could use these very formal methods to create an element, add an attribute, and all that kind of stuff, which was much more verbose, but made sure that you were generating valid, or at least well-formed XML, et cetera, as you went along. We can persist. We can load these to and from files. You can pull them in from streams, or you can just take a string in memory and parse it. And so with the XML namespace out there, we have the XML document that represents the overall document. We've got XML declarations, comments, elements, attributes, text nodes, etc. So for basically every type of structure that you could have in the actual XML document, there's a corresponding type in the XML namespace over there. And they all derive from this root class of XML node. And I'll actually come back to that in a second here and look at the alternative to that, which is link to XML. And so link to XML says, take all that goodness that I loved about link and allow us to do it over the nodes that are inside an XML document. And so here we're kind of focusing on that one slice of link where we've got an XML document, I've got some .NET language like C# on the other end, and then I've got this link to XML set of objects and classes here in the middle that I can use to make dealing with XML much simpler. So much like we had in the system.xml, I have the system.xml.link namespace, and again, we've got corresponding objects as we work down through those. And I did mention just even creating XML is so much simpler in link to XML because each one of their creation constructors can take another one as an argument. So I could just nest these things up and very quickly create some very complex and cool data. All right, so let me jump back over here. I'm going to try and speed this up just a little bit. But if I go back, remember my good old link to SQL here, or sorry, my SQL database. Let me open another script. One of my favorite ways to generate XML is from SQL Server itself. So here I've got some just good position data, etc. out there, and I can come in here and query it, and you'll notice I'm getting this relational database back, or relational result set back, sorry, etc. And I'm even doing joins and joining places and countries and things like that back together. But if I want to get that back as XML, I can add in this for XML, and then there's various things that we can tack on here at the end. But this is going to pull those path data back, or each row as an element called position. It's going to wrap them all up in a root element called positions. It's going to put my position ID and my cruise as attributes, but reported at region and country, latitude and longitude as child elements. So let me go back here and run this whole query here. And you'll notice that now instead I get back this XML result. And if I click on it, it'll open it up. And so out of that relational SQL data, I just generated this XML. And it's this hybrid, some things are attributes, some things are child elements, etc. I love that. That is so cool. But anyhow, now that was all of my rows. I got like 1,183 positions in there. I don't want that many, so I'm just doing at most go grab 100 of them and only grab every 10th one out of cruise 1 or 2 for me. So this will be a smaller sampling of them. But they're, it's just the same structure. So great way to generate some XML data out of your relational databases out there. Cool. So I've actually already done that. Let me go back over here. And I'm going to add in existing item. And change to the XML data type, data files. And I'll just pull a sampling of positions, not the whole data set back. OK that in, and I want to make sure that this gets copied into my output directory, so I'll say copy it as long as it's newer than what's already out there in that output directory for me. Cool, and so now I have this ability to go in and process this XML data. So let's go back and look at kind of how maybe I would do that with the old link to XML, or sorry, with regular XML. And I'll copy these guys in here. And I've got this method here called walk the DOM demo. And I got to pull in my system.xml namespace. So there we go. All right. So this guy is going to go pull in that positions sample XML document by grabbing an XML document and telling it to load that file. And at that point, it's going to check for well-formedness and make sure that it looks like a good structured document. And then from there, I can get the root by asking for the top level document element out of that XML thing. And then what I'm going to do is go recurse it. Now, all I'm going to do is basically report out the name of the node with a certain number of spaces in front of it, and that's the level. So we'll start out at 0 spaces, so it'll be all the way up against the left, and then the subsequent ones will add 1 to the level as we recurse into them, so it'll start to indent as it goes down here. If it has any attributes, though, this is kind of ugly. I have to ask the node if it has attributes, and if it does, then I have to iterate them, and then I have to go show them. I mean, this is tedious code. It's like all this stuff just to be able to walk this tree here. If I run it, it works, but that's kind of tedious code to have to go in and do that. So that's sort of the old system.xml way. With the link to XML, though, I've got some much nicer things that I can do here, right? So let's go just grab this. Look how much nicer this code is. So this is going to be my link to XML demo. Let me just copy that method name. And this time I got to pull in the system.link namespace, right? So this one's going to do the same thing. It goes and loads in the sample data, but now I can go in and ask for all the position elements. I can do filtering on them where the attributes value is 2. This would be so much harder to write back over in the traditional DOM-based processing of that. Do I not have a way to show those? Here, let's loop through them down here. Well, here, I'll just walk up to it. I'll stop the demo at this point, but let me run through it and I'll show you the data. So I'm going to I'll just run up to the cursor here. Control F10 to run the cursor. There we go. And so now if I look at this results set here, there we go, sorry. Look at the results set, and I can expand the results view and notice that I got this really nice, collection of elements that are all coming back from this. Actually, I do want to show you one more thing. Notice that what was coming back here is still a bunch of X elements. I'm still getting XML-ish things back, if you will. Link can do what are called projections. I can project this into a new anonymous type. You can also use concrete types if you want to. I just won't take the time to do it. But I could say, hey, where the position, create a new object with a property of position and set the position value equal to, and we'll go get, and p.attribute, position ID, and then I could add in the latitude, and basically it's the same process, but I'll do it double. And it's the element. And one more time for longitude. All right, and then I could go off and do something with that data, but let's just run it and see it. And if I go to Cruise 2 here, notice now that what I have in here is a nice collection of objects with properties and all that good stuff on them. That is so cool. I mean, that's awesome stuff. So anyhow, with that, hopefully then that gives you a good overview of different types of data access technologies that we have available to us. And so we'll go ahead and take a little break. When we come back, we're going to talk about Entity Framework and so sort of extend this discussion a little bit. So 10 minutes. We'll be back.